All right, welcome everybody. I'm using a new program, so ignore this red beeping type of video recording thing. I can't get rid of it, but yeah, let's do this. So here, first lesson on derivatives. We need to review average rate of change. This video will be very short and sweet. So here, average rate of change from a graph. Here we have the function y equals f of x is graphed below here in the red. It says plot a line segment connecting the point on f where x equals -3 and x equals -7. So here, when we talk about a line segment, so a line segment will look something just like here. We have a line with 2 dots towards the end. That's a line segment, and connecting the points on f. So this graph here is the function f. So here we look at x equals -3, x equals -7. So if we actually get a chance to zoom in, and there we go. Here, this is our x-axis, this is the y-axis. So here at x equals -3, this is the first point over here, and at x equals -7, this point is over here. And all we need to do is just connect a line segment that connects these 2 points, right? Now, what do we want to do next? It says use the line segment to determine the average rate of change of the function f of x on the interval from -3 to 7. Okay, so here, notice that to find this rate of change, all we're doing is finding the slope, right? And to calculate average rate of change, we just need our handy-dandy formula, which shows that the way we read this triangle, read it as delta y, or the change in y, over the change in x. So this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And now notice that here, this is our first point over here. This x value is -3, and we just have to look within the graph, what is the y value? Notice that the y value, these should be negative values. This should be -12. So you have -3, -12, right? So notice that this is your x sub 1, and this is your y sub 1. Right? Okay. Now let's look at the next point over here at +7. Notice that our x value here is 7, and what is the y value that corresponds to it? It looks like, let's say it's 14. I messed up. Maybe it should just be, let's just say it's 14. Okay. And then here, notice that this is our x sub 1, y sub 1 here. We'll say that this is our x sub 2, y sub 2 over here. And all we need to do is just plug in these values into the average rate of change formula. So here, let me zoom out a little bit. Oh, that's too much. Okay. And wait, let me zoom out a little bit. Okie dokie. Nice. So here, our change in y will be y sub 2 minus y sub 1. Our change in x will be x sub 2 minus x sub 1. Right? So here, just rewrite the formula. We have change in y over the change in x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Here our y sub 2 is 14 minus a -12 over, and for our x values we have 7 minus a -3. Okay, and then here we just use simple algebra. This is going to be 14 plus 12 over 7 plus 3. And then let me zoom in a little bit so we have a better angle, and our average rate of change will be 26 over 10, or you could simplify it to 13 over 5. Okay, and that's really it. That's just a quick visual of what the average rate of change looks like visually, and algebraically this is how we calculate it. Okay, that's it. Try and work on some delta math questions that correspond to this. I'll see you.